Good morning. Welcome to another session of MCN201 Sustainable Engineering. In the last session we had seen the ISO specifications, and today we will see life cycle analysis, abbreviated LCA. Before proceeding to the slides, we will see a quote. If you really think the environment is less important than the economy, try holding your breath while you count your money. So today we are discussing the scope and goal of life cycle analysis. We are in module 3 right now. What is life cycle analysis? Life cycle analysis is a tool to evaluate the environmental effects of a product or process throughout its entire life cycle. So as this picture clearly indicates, here we have the raw material extraction. We have to see the environmental effects of this stage, that is the raw material extraction. Then the material processing, manufacturing, distribution or transportation, and usage by the consumer, and this is the end of the life. So at each and every stage we have to evaluate the environmental effect, and that is precisely life cycle analysis. So it entails examining the product from the extraction of the raw material for the manufacturing process through the production and use of the item to its final disposal. So it looks into every stage of the product till it goes to the waste. It is basically a cradle to grave concept, where cradle refers to the raw material extraction and other stages, and grave refers to the disposal stage. An example is shown here. This is the material extraction stage, then the product development stage, then the completion stage, the usage stage, and finally the end of the life. So this assessment includes identifying and qualifying energy and materials used and wastes which are released to the environment, assess the environment impact of each and every part of this particular stage, and then look at possible improvements in reducing the environmental impact. LCA has emerged as a decision support tool for areas like businesses, regulations and policy, and to structure technology development in a coherent way. You can see these are the different stages: material extraction, formulation, processing and manufacturing, distribution and transportation, product use, reuse and maintenance, recycled products, components and materials, and the waste management. And in each stage there are inputs and there are outputs. So we need to closely look what are the various inputs like materials, energy, water, air, etc. And also we have to see outputs like principal products, co-products, water effluents, airborne emissions, solid waste, other environmental interactions. So at every stage, we have to look at the inputs and outputs and its environmental impacts and reduce to the environmental impacts. So the various stages are extraction of the raw materials. So you have to keep an inventory of what are the different raw materials for the production of the machinery involved in the manufacturing of the product. Collect all possible data for the raw material extraction stage, but it is a very complex task. The second stage is the manufacturing of the product. So it involves the raw material plus other energy, water, etc. So you have to look into the production of auxiliary materials, chemicals, and whatever outputs it produces. The next stage is the transmittation. Here we use a lot of energy in moving the final product from the industry or factory to the consumer premises. It can be transported by road, rail, water, or even by air transportation. So you have to look at which transportation leads to the least environmental impact. But this need not be cost effective always. Then the usage of the product. So how you use the product, and then if possible recycle it. And finally the last stage is the waste management. So here reuse, recycling, incineration, composting, wastewater management, and landfilling. The limitations are the data quality and the life cycle boundaries. Country specific technology types and the evaluation stage priorities. Here you can see the procedure for LCA. It consists of 4 different phases: goal and scope definition, inventory analysis, impact assessment, and finally the interpretation. In goal and scope definitions, we define the parameters of the assessment, such as the product system to be studied, the system boundaries, the functional units and assumptions. Inventory analysis includes data collection, data calculation, and allocation. The data is collected on the inputs, energy requirements, raw materials, and ancillary inputs. Allocation partitions the inputs and outputs between the product system, industry, and other product systems. Impact category selection. This is the first stage in life cycle impact assessment. Then classification. Organize and combine LCA results into impact categories. For example, the item can be classified into those causing global warming, those causing acid rain, and so on. Then characteristics. It is based on the scientific conversion factors to convert and combine the life cycle inventory results into representative indicators of impacts to human health and ecology health. And finally, the interpretation. This phase combines the findings of the life cycle inventory analysis and life cycle assessment. It includes finding in accordance with the goal and scope. It identifies the findings and presents them clearly and consistently. What are the benefits of LCA? It helps decision makers. LCA data identifies the data transfer of environmental impacts from one medium to another. There are a lot of limitations. LCA requires a lot of resource and time. collection of accurate, realistic, precise and reproducible data is a very difficult task. And LCA will not determine which product or process is most cost effective. Product life cycle models we can divide into 3 or sometimes 4: cradle to cradle, cradle to grave, cradle to gate. Cradle to grave is the full cycle life cycle assessment from resource extraction to service life and disposal. Cradle to gate is an assessment of partial product life cycle from resource extraction to the factory gate. Cradle to cradle is a specific kind of cradle to grave assessment where the end of life disposal step for the product is recycling process. And finally, gate to gate is a partial LCA looking at the value added process in the entire production chain. These are some of the references, and with that I am Dr. Unnikrishnan, PC, signing off. Thank you very much.